Good morning, everybody. Thank you for coming this morning. This is part of where we will see how we would like to have give access CFD and optimization to everybody, so everybody can do simulation, everybody can optimize. And this is what you will see in this part of democratizing CFD and optimization using NUMECACloudPower. And this is unlimited high performance computing resources. And then you can now start thinking of using your operating expenditure than capital investment. Okay. So if we go to this, yes, okay. We come back to Thomas' presentation this morning that we have this beautiful boat, classical one, but we want to modernize this with our current technology, with electrical motor, but with also better performance. And the customer asking to submit the result, at least the design, by tomorrow. And Thomas said it's about 1 week or 10 days in total. Can we do it? We'll see what we need. In Thomas' presentation, you need to run many CFD computation. You have 32 samples for initial database with 6 CFD runs per sample, 56 samples for surrogate-based optimization to work on it. And if you do that, and with your limited on-premise resources, we'll try to make a math now, okay, together. We'll see, you have 2 seats of NUMECA license, 2 seats of Fine Marine, or with Fine Design 3D. You have 1 workstation to 28 cores. This is what we learned from the first presentation. And then we need to generate at least 528 CFD in total. And this, with the average that we heard this morning, is between 20 minutes to 2 hours, with an average of 1 hour for all computations, then it will take 11 days. So what happened then? I can only tell my boss, oh, no, we will lose this project because we cannot submit our result by tomorrow. But we have this NUMECACloudPower, and in NUMECACloudPower, you will have access to any NUMECA software. You will have via just your web browser, no installation. This is on the cloud. And unlimited core numbers, unlimited seat of software. You can have multiple machines, and this is having what we call auto scale. You can scale up, scale down. You can stop your machine, you can start your machine, and you pay only when you use the machine. And for this, we partner with Azure Cloud HPC containers, the one that create the easy way to use high performance computing on cloud, and our partner Microsoft Azure Elastic high performance computing platform. And this is a container, is a portable tool, and it can be moved from your own on-premise installation. You can install this, and then you will work on your web browser to run heavy computation, or you install this in the cloud as well. You will have the same experience. You will keep your workflow either on-premise or on cloud. You change the HPC provider, this will also be valid. Your established workflow is your workflow, no learning curve. And with Azure, we have access to 60 data centers, 140 countries. Of course, for HPC on our side, we may limit it to some accesses, but worldwide We have already customer in New Zealand, in Hawaii, in US, mostly in Europe. We have machine in Tokyo, in Singapore. So those are really good. Now, using this, we can tell our boss and our customer, we can optimize. We can have an improved design by running on 1,400 core clusters. So instead of having only one workstation, 28 cores, now we have 500 more times, okay? And unlimited seat number of FineMarine and FineDesign 3D for the optimization. And here, on the 528 CFD runs that will require about, if we use 14 cores, 1 hour, then you need 7,400 core hours. And with this 1,400 cores, you can finish it on part simulation less than 6 hours. And then you see during the day you still have 3 hours to do analysis, data mining, your first report, and then tomorrow you can submit the result to your customers. So this is really, really important to see that time now we can compress if we need, using high performance computing on cloud, using NUMECACloudPower solution. Other typical application that Benoit mentioned in his presentation is, the maneuvering. You have, this is coming from Technical University Berlin, the zigzagging. It takes a lot of time, a lot of resources as well. So either you queue in classical high performance computing supercomputer, and then you have your slot, you run it. But with NUMECACloudPower, we have thousand unlimited resources. There is no queuing, and the machine is dedicated to you. This is a zigzag. We'll see it together. Can we do it in one day? This kind of simulation you see here. You have contra-rotating propeller. You have the movement of zigzag. The movement on radar is very complex. Takes time. Another one is turning. Normally you do this in weeks. Okay, with limited resources. The Benoit also has shown this part of cost keeping. You have different angles, fully function. Can we do it quickly? Of course, yes. The other part is this is the turning circle. If we have access to 5,000 core for this 360 turn, and having this, you can do it in one day. So this is really nice now. Zigzag with 2,500 cores with 3 overshoot with physical times of 22.5 seconds, we can do it in one day as well. You have curve skipping. For one wave angle, just put 1,000 core. You can do it in one day. You have 4 wave angle, you book 4,000 cores, you do it in one day. Okay, so this is really powerful. What is the one that also Benoit mentioned about velocity performance prediction? Dynamic VPP is transient case with Finocom. And we have also solution with matrix. Then you need to run between 80 and 200 simulations, resistance, different condition. It is automated in FineMarine with CVZ, but still, if you have limited resources, then you may need months or 1 month or some weeks to finish that. Okay, just show this dynamic thing. Can I play this? Yeah, it seems that my video doesn't work. Okay. doesn't matter. Normally you will see the video here, but then this is transient, and this is the time that needed. If you book 2,000 cores, say with standard VPP, you want to have 200 points with resistance, with the number of cells around 1 million, 1.5 million to 2 million. It can be done in 50 core hours per point. That will need less than 1 day on 2,000 cores. Dynamic VPP is one transient simulation. It's transient anyway. Then you can have many conditions for VPP and transient if you want by booking this. Okay. If you have any comment, you can raise hand and write your questions. We can discuss this later. How does it work? I will show you a sneak peek of Omnis, not on Marine, but you will see that. I hope my video will work this time. Just wait. I will just change my. Yes. Okay, that because I was in my pointer. Just to back to here then. You see here. So this is really nice too. It will find its equilibrium automatically, and it can be done with our access to NUMECACloudPower today. How does it work? When you book, you will receive an email like this one. Okay, in this email you have two parts. One is the management of your machine, and the other one is access to your machine. Everything is in your web browser. You go into the management of your machine, and then you see this, your cluster. You have one master node with two execute nodes having 120 or 60 core per node, so you have 120 cores, and then you can start and you can stop. So you pay only when it is start. So we turn on now all the execute node, and once the execute node are there, they are on, then you can access to your machine. You have the password, you have the credential, you go into your container. So you see here on your web browser, but you can have a look and feel as well as it is your machine. We will open Omnis. From here, you can monitor the usage. You can even shut down your machine. And if you look at here, you will see here 60 cores on the execute multiplied by 2. And here we will run a computation. You can see the 120 cores are fired up when you run the simulation, and then you can follow this. You will see it becomes red, and you will see, yeah, now it's going up, and now we can follow how the conversions are. So when you finish this, we can then stop the machine, and then the counter stop, and your consumption is only computed when the machine is on. Okay, now here we come back to your machine. I want to add more nodes. So here I have access even to 2,000 cores. I will add two more nodes. And if you look at this, I have more quotas here. I can add more, but I just put 2. And then you see here, my core numbers become 240. So it's really up to you. Then you can turn off your machine. You will see your machine on the web browser. It will become white now when it is turned off. You see, now you can also have several machines. A GPU base, you can have different machine in different area of the world. Here, for example, we have 15 machines located from North America, Europe, Asia, Singapore, India, Australia. So if you are a global company operating from different parts, you can have those machines near your engineers as well. If you You are mobile, you move, we can prepare the machine for you on those areas. Again, just to summarize, it's a real HPC on demand. It's unlimited hardware and software. You are the user. You are the one who control the usage. You can start and stop the machine when it's needed. When the machine is not active, the CPU activity is monitored, and then when there is no activity, then it will auto stop. And when you need to scale, you can scale by yourself, or we can also put in place an elastic part where if your job require more, then the system will auto scale to the number of core you need, of course, within your reservation. So we see different type of application function. You see at NUMECA, of course, we work on marine, but also on different part. And this type of application, full multiphysics, optimization with neural network, with AI, full transition flow simulation, not in weeks, not in months, not in days, do it in hours now. Okay, so you can unlock your innovation now. What is impossible today, we make it possible now. And we don't talk anymore about capital expenditure. We move to operating costs, operating expenditure, where if you have your customers, you can put this in your project cost. Okay, I think that's my part. I don't know if I have time for questions, but yeah, thank you for your kind attention.
Thanks, Archie. There have been a few questions. Probably the most important one, what about security? What about if I do customer cases and we have non-disclosure agreements? Can you ensure that the data is safe here?
Yes.
Or how can we ensure that?
Definitely. Our data center is Microsoft Azure, and they are all certified with ISO 27001 that make the data center is secure. Okay. And you have your own credential, you have all secure. In the container, in the Docker container itself, you have a different level of securing your access and your data. And even us at NUMECA, when we deliver this, we cannot access to your machine, except, of course, if you share your credential with us. You need to change your credential on your own when you receive it, but everything is ensured by first NUMECA, but then by the container, Docker, and then by the data centers. And this machine is yours. It's not shared with the others. Your storage is yours. It's not shared with the others, which is different than I think the other, or maybe back several years where you have a chunk of storage shared with the other, but this one is really dedicated to you. No one can access except you. Okay.
Okay. Thanks, Archie. Then I would say it's time for our next contribution here. This will be presented by Stefan Harries from Friendship System. I will quickly make you the moderator, and then you can show us something about the CAD optimization that you have done.
Thank you.
All right. Can you see my screen?
For me, it is working.
Okay, and you can also hear me. Excellent.